Okay, thinking about building this engine. It is a double acting 28 cylinder engine. Okay, this is actual size. All right, I have a 1-inch cylinder that's double acting. The valve is exposed when it's at the end of the travel. See, this is about to fire, and then it'll fire down with a central exhaust port, okay, to a crankshaft and a little oil pan here. It is a horizontal engine, and the shaft rides on these bearings. Anyway, my question is about balance. So I have this one cylinder here. It's one cylinder, and then the other cylinder's directly across from it. There's a small gap in the middle, but they're directly across from each other. There is no, they're directly across from each other. Here's the engine layout. Rough engine layout, mind you. I'm more really of a just build it than design it, but it had to be done. So yeah, here's the rough engine layout. The gap in the middle, which is this gap, and then between the two cylinder banks and then the other two cylinder banks, but they're directly across from each other, okay? And then the crankshafts are obviously on the ends. So there is no cam. It all works by that little gap being exposed and it firing during that little gap, and then the fact that there's 28 cylinders and they fire every 27.5 or no 25.7 degrees, 360 degrees. Forget the 30% there. I was just not doing the math. But anyway, so here's the actual engine layout. I have 8 of them firing at once. Okay, they're only 1-inch cylinders, but I have 8 of them firing. So yeah, so you have 8 of them firing at once, and in my mind, because I have this one firing to the left, if you will, and this one, which is directly across from it, firing at the right, that should cancel out primary. Okay? And then because I have them firing in an X, if you will, that should cancel out secondary. I'm no engineer. This is actually going to be a rather large engine. I want to say it's, what is it? I want to say it's going to be 27 by 40 inches by 12 inches tall. It's going to be a rather large engine, 28 cylinders. The 1 inch is because that's what the that's what a 1.5 inch extra strong cylinder comes out to be. It comes out to be 1 inch cylinder, 1 inch ID inside diameter. But yeah, just sketches and such. But yeah, with 8 of them firing at once, do I need weight on the camshaft? Because right now I have no weight. This is just showing a rotation of the camshaft. Pretty simple camshaft. Crankshaft. Jesus. Crankshaft. Pretty simple crankshaft. And yeah. There's nothing in the middle here. This is open air. But right now I have no weight on this thing. And I need to buy a mill. I need to drop like $2,000 on a mill. But once I get the mill, I'm going to start building this thing. And what's really stopping me right now, I mean, if I just want to throw it on my credit card, I don't like to, but what's really stopped me right now is not knowing if I need weight on this crankshaft or not. I do not believe I do. But like I'm saying, I'm no engineer. And yeah. So yeah, little high pressure chambers, exhaust. It's not packing. It's not a very complicated engine. That's kind of the point. And yeah. Uh, but what I need to do is, yeah, the volume's an issue. If you didn't notice that, the actual volume of the pressure going into each cylinder is going to be an issue. But this is, I mean, yeah. So 8 fires every 25.7 degrees. And that'll just continue. So, I mean, there's going to be a little bit of force, and this has no rings either. This is just the cylinder inside of there. It only fires there. I know it's not terribly efficient doing it that way, but I can't have oil with this system I'm using. I can't have any oil. It's a closed system. So, I mean, there's oil right here around these bearings. There's a vent. There's oil, obviously, in here. It's just going to splash. I'm only hoping for 1500 RPM, which is, considering how many firings that involves. Here, I think that's the math. So yeah. But I don't know. I really need to reach out and grab a engineer, and you're an engineer, so I'm throwing this at you. Like I'm saying, I don't think I'm gonna have an issue with balance. On the other hand, if I'm going to have an issue for balance, I want to fix it at this stage. So, I mean, because while I don't think the thing's going to rotate or vibrate terribly bad, I don't want it to. I want to minimize that. So, yeah. So we're 7 minutes in. I'm going to end this, and hopefully you can look it over and get back to me. Thank you.